Today, we wanted to start talking about understanding rational and irrational numbers. Uh, Up to this point, we've been dealing mainly with rational numbers, but we're going to go back and use the chart that we made the, with all the square roots and cube roots, perfect squares and perfect cubes, in order to work through this coming unit. The name of the unit is Understanding Rational and Irrational Numbers, and before we start, we need to look at some new vocabulary and review some old vocabulary. So the new vocabulary, we're going to use a term called irrational number. So an irrational number is a number that cannot be expressed as a quotient of two integers, a terminating decimal, or a repeating decimal. Second term we're going to talk about are real numbers. All rational numbers and irrational numbers are part of the set of real numbers. And then for review vocabulary, we're going to talk about the term equivalent. Equivalent is having the same value. Example of that is 36 over 9 will reduce down to 4. So 36 over 9 and 4 are equivalent. Estimate is to find a value that is close to the actual value. We're not going to know the exact value, but we're going to get close, and that's what we do when we estimate square roots. All right? And then the last term is rational number, and if you look at the definition of rational number, you'll find it's the exact opposite of irrational number. So a rational number is a number that can be expressed as a quotient of two integers, a repeating decimal, or a terminating decimal. And if you look at the irrational number, that's a number that cannot be expressed as a quotient of two integers, or as a terminating decimal, or as a repeating decimal. So we need to make sure we understand that these two are exact opposites of each other, and if we do that, then we'll be able to understand most of what we want to do in this lesson. So the objective of this lesson is to understand what rational and irrational numbers are. And these two definitions are what we're working to get an understanding of. Then we need to be able to identify rational and irrational numbers. So when I give you a number like the square root of 2, is it rational or irrational? Well, we'll have to find out based on these criteria, all right? Then we need to express our repeating decimal as a fraction. We're going to learn how to do repeating decimals as fractions by estimating. All right. We're going to estimate square roots to the nearest hundredth, and we're going to compare and order rational and irrational numbers on a number line, and estimate the value of expressions. So let's go ahead and get into the lesson. If you'll turn in your books. Turning your books to page 24, then we can go ahead and start. So we're going to start talking about, think it through, what are rational numbers? Well, rational numbers are those numbers that can be written as a quotient of two integers, and then since the bar of a fraction represents the word division, every fraction whose numerator and denominator is an integer is an actual number. So by that we're saying if we have integers like 4 divided by 4, and the answer is a 1, then that is a rational number. But if it doesn't, then it won't be a rational number. It has to end up as either an integer, a repeating decimal, or a not a terminating decimal. All right. So any number that can be written as a fraction whose numerator and denominator are integers is also a rational number. Okay. Think about this: every integer, whole number, and rational number is a rational number. Every integer, whole number, and natural number. And remember our real numbers, integers. Remember they start at 0 and they go in both directions, positive and negative. And natural numbers and whole numbers are almost the same. Whole numbers start at 0 and go in a positive direction. The only difference between the whole number and a natural number, the natural numbers are sometimes called the counting numbers, which means that when you count, what's the first thing you say? 1. So the counting numbers start at 1 and go in a positive direction for infinity. So the only difference between these two is that 0 is in the whole number set, but not in the rational number set. All right. Now you can write every integer, whole number, natural number as a fraction, so they're all rational numbers. What that says is, like the integer 3 can be written as 3 over 1, right? So that makes that a rational number. Negative 5 can be written as negative 5 over 1, which makes that a rational number, all right? And 0 actually is, because if you divide 0 by 1, you get what? 0, remember? 0 divided by any number is 0. All right, now the square root of a perfect square is also a rational number. Where we have to make that distinction is that between these perfect squares is what we're going to start learning how to do, right? How to find those values. But we know that the square root of 1 is 1. That's an integer, that's a rational number. The square root of 4 is 2. Again, an integer and a rational number. The square root of 9 and the square root of 16 are both whole number rational numbers, right? Let that go. There it goes. All right. Every terminating decimal is also a rational number. If you think about that, if a decimal ends, then it's a rational number. Because we know that if we have 4/10, that's 0.4, right? Which means it's going to be 4 over 10, right? 4 over 10 reduces down to 2 over 5, right? So that's still a rational number because it stops, it ends, right? 75/100 works the same way. We get 75 over 100, right? And that's going to reduce down to 3/4. Again, that's a terminating decimal. It stops right at this point. 0.386 is 386 thousandths, and again, it will terminate because it terminates right here, right? And then the square root of 16, square root of 0.16 is 0.4, right? Because 0.4 times 0.4 gives you 16, and you count your decimal points, you got 2 of them, so you get 0.16, all right? So the second thing we're going to talk about is how every repeating decimal is a rational number. And we can write repeating decimals as a fraction, and in order to do that, we have to go back and think about equivalencies, right? So in this case, we're going to use the repeating decimal of 0.3 repeating. And when you look at that, you have to say, we're going to use the value of x. So we're going to do a let statement. We're going to say let x equal, let x equal. And we're going to let x equal 0.3 repeating. And then the next step is to go ahead and multiply that by 10 because it's in a tens place, right? So we're going to multiply that by 10 and get 10x, right? 10x is equal to 10 times x, right? Which will give us 10x is equal to 3.3 repeating. And now we're going to remember that 0.3 is equal to x. And we have 10x minus x. We're going to write that out. We're going to say 10x minus x, right? And we got to remember that's equal to, what was 10x equal to up here? 10x was equal to 3.3 repeating, right? So 10x was equal to 3.3 repeating, and x was equal to 0.3 repeating. So 10x minus x is 9x, right? And 3.3 with the 3 repeating and 0.3 repeating, when you subtract that, you get 3.0, all right? So remember, these are equivalent expressions because 10x and 3x are equal, and x and 0.3 repeating are equivalent. So now we have 9x is equal to 3.0, and we're going to divide both sides by 9 because we want to do the same thing to both sides. And we end up with 9x, which will give us 1x, and then 3 divided by 9 is 3/9, which reduces down to 1/3. Okay, does everybody follow that? If not, I'll ask Coach to give you a couple minutes to discuss it in your group if you need it. All right, just let Coach know. Hold up your hand if you need to have him stop the video and discuss that. Now, we can do the same thing with larger numbers. The difference here is that whatever this value is, that the last number is, in this case, that's a tenths, that's a hundreds, and this is the thousands place. Whatever value that is, that's what we're going to multiply by. So in this case, we got 0.512 repeating. So it's 0.512 repeating. And all that's repeating. So we're going to do the same thing we did a while ago. We're going to write that out as, we're going to multiply it by 1,000. And we multiply it by 1,000, we get 512.512 repeating. All right, so now we're going to do the same thing we did a while ago. 1,000x minus x, right? Because x is still 0.512, right? And then we're going to make that equivalent expression. 1,000x was equal to 512.512x. So we're going to keep that. And then we're going to subtract the value of x itself, which was 0.512, repeating. So if we subtract those, we get 999x and 512x, 512.512 repeating minus 0.512 repeating just leaves us with 512, right? So that 512 now is divided by 999, because we divide that, we get 1 there, divide it right here, and we get x is equal to 512 over 999, right? So what I want you to do now is to look at the reflect problem, and we're going to work this in our group. Each person try to figure out by doing the same thing we did here on this reflect problem. We want to know what fraction is equivalent to 5.1, and is 5.1 a rational number, and you need to explain that. All right, so I'm going to ask Coach to stop the video and give you 4 to 5 minutes to look at what we have. We have 5.1, which is 5 1/10. So let's look at that as a mixed number, 5 1/10. 5 1/10 is equivalent to 51 over 10, right? Is that not right? And 5 1/10, if you look at that, 5 1/10 leaves you a whole number of 5.1 and 1/10. So that number is a terminating decimal, right? 1/10 is 1 over 10. You divide that out. 1 divided by 10, and you get 0.1, and it's done, because 1 times 10 is 10, and you get 0. So that is a terminating decimal. And so it says, is it a rational number? Yes, it's a rational number. Yes, 5.1 is a rational number because it terminates. Right? So because it terminates, it's a rational number. And that is all you need to be able to do in order to determine if it's rational or irrational. Does it terminate? Does it repeat? Or is it a whole number? Okay? So terminate, repeat can be written as an integer. And then that is all for today. Your homework, actually your homework is going to be pages 23 and 24 in your homework book. Just make sure that you get that ready to be turned in tomorrow. If you need any help, you can always email me at my school email, rmcgee@sarita.net, and I'll give you all the help you need. All right, thank you.